Hey Taylor, so I hope you're doing good. In terms of the pictures you sent me, all five of them fall into one of two categories. All right. So in terms of the pictures one, two, and four are all the same type of question, and then pictures three and five are also the same type of question. All right. So I'm gonna teach you how to do one of each type. All right. I'm gonna do numbers three and number four in terms of the pictures you sent me. So the third picture you sent me, I'm going to do, and the fourth picture you sent me, I'm going to do. And then hopefully after I teach you how to do those, you can figure out how to do the rest. All right. So we're actually going to start with the fourth picture, which reads, a student ran the following reaction in the laboratory at 240 degrees Kelvin. All right. And then it gives us this chemical reaction. All right, so for these types of questions, the first thing that you want to do is you're going to want to write out what Kc is. And we've been doing this for a little while now, so I'm sure you know how to do it. But just in case, Kc is always just the concentration of the products, divided by the concentration of the reactants, right? We've been doing this for a little while. It should be pretty familiar. Just the concentration of the products multiplied together divided by the concentration of the reactants multiplied together, right? And then the coefficient is always just whatever coefficient is in front of the products or reactants, right? So in this example, our chemical equation is 2NOBRG, and we got this equilibrium sign, 2NO plus Br2. All right, that's our equation. So Kc, which is products over reactants, is just the concentration of NO, and that's NO squared, right? Because there's a little 2 here, so that means we got to make this NO squared. All right, times the concentration of Br2 over the concentration of NOBr, and then squared, right? And this is also squared because there's a 2 here. We know how to do that. All right, so that's the first step. After you write out that equation, the next thing you're going to want to do is you're going to want to make a table. All right, and the way you're going to make this table is in the top left corner, you're going to write concentration. All right, concentration in moles. Now, thankfully, all the moles that they give you are already transferred into this big M molarity right here, so you don't have to do any equations. Basically, all that means is you can just take the numbers they give you and put it directly into this table. So you're going to write concentration, and then you're just going to write the equation again. All right, just the same equation they give you over here to the right side of this concentration. Now make sure you write it so each species has enough room under it so you can put some numbers. All right, you don't want to make it too close together, otherwise you'll be cramming to fit numbers in. All right, so it's going to look like that. You start with concentration in the top left, and then you just write your equation. Now, under the word concentration, you're going to write 3 things. You're going to write starting, all right, starting concentration. Under starting, you're going to write change, all right, that's the change in concentration. And then under change, you're going to write equilibrium, equilibrium concentration, all right? And then all you do after after you filled out this table is you're going to plug in the numbers that it gives you. All right, so I'm going to read the question. It says, when she introduced 0.159 moles of NOBr into a 1 liter container, she found the equilibrium concentration of NOBr to be 0.122 m. All right, so that first line says when she introduced 0.159 moles of NOBr. All right, now whenever you see that word introduced, it means starting. All right, so anytime you see a number that comes after introduced, you can put it in this starting line on your table. All right, so it says she introduced 0.159 moles of NOBr. All right, so under our NOBr here, we're just going to put 0.159. All right, you see how it's on the starting line because it says introduced. And then it's under NOBR because it says it's 0.159 of NOBR. Not NO, not BR2, just NOBR. All right? Now, it doesn't say anything else was introduced. It only says NOBR was introduced. So since it doesn't say anything else, we can just put zeros for these other two right here. All right? Let's move on. So then it says she found the equilibrium concentration of NOBR to be 0.122. All right, so just like the last time, we're going to find equilibrium because it says the equilibrium concentration of NOBR was 0.122. So we find NOBR, and then on the equilibrium line, we put 0.122. All right, now to find the rest of this, all we got to do is a little bit of math. All right, so if you want to imagine this middle line as the math line, all right, so this line is basically saying what math do we need to do to get from this number to this number, all right, what number do we need to put in here? So for example, we start at 0.159 and then we go to 0.122. So what number needs to go right here to go from 0.159 to 0.122? Well, it's obviously 0.037, right? Because 0.159 minus 0.037 is 0.122. All right, simple enough. Does that make sense? All you're doing here is you're trying to get from this number to this number, and you're trying to figure out what math goes here. All right, so in this case, you just subtract 0.037. Now, our rule in chemistry is whatever you do to one side, you have to do to the other. All right, so since we subtracted 0.037 on the left side, on the right side, we're going to add 0.037 to each of these. All right, so now we have positive 0.037 here. And then normally we would put 0.037 right here, just like here, right? But since there's a 2, we actually have to multiply that 0.037 times 2 to get this number. All right, does that make sense? So if there wasn't a 2 here and it was just NO, we would put plus 0.037, just like it is with this BR2. But since there is a 2, we're going to multiply this 0.037 times 2 to get our number. And that's going to be 0.074. All right? And then after you do that, this is just the same, right? We're just going to add these two together to get our numbers on the bottom. All right, simple enough, right? So since this is the math line, we're just adding 0.074 to our 0, and that means our total is 0.074. You can imagine it almost like an addition table, right? You're just adding these two together to get this one, adding these two together to get this one, adding these two together to get that one. And that's all it is, all right? So now that we have our equilibrium concentrations, we can just take these and plug it into our equation right here, all right? So now we have Kc is equal to, it's NO2 squared, NO squared. So we see where's our NO? Here it is, 0.074. So we write 0.074 squared times our concentration of Br2, which is 0.037. Now make sure you're always putting in the values on the bottom line, all right? None of these lines up here have anything to do with our equation. Just this bottom one, the equilibrium one, all right? So we got these two numbers over NOBR squared, right? Just like we found in the beginning. And that's going to be 0.122 squared, all right? And then you just solve that out, and that's going to be your answer. Now, it's important to note that in the other questions that you sent me, they're not always going to give you the same parts of the table, all right? They may give you these numbers right here, but not any of these. Or they may give you these last numbers here, but none of the top ones, all right? It's important. The only thing you need to remember is whatever you do to one side, you do the opposite to the other side, right? So we subtracted 0.037, and then on the other side of this equilibrium sign, we added 0.037, all right? So as long as you can remember to do that, and remember to change it if there's a coefficient, yeah, then you should be all set. So that's how you do problems 1
2 and 4.